I'm Scott Kuroda.
And I'm Rick Wong.
And we had a digital temperature sensor.
Yeah. And so, we have a digital temperature sensor, and we interfaced it with Microblaze on Nexus 2 board. And the sensor itself is on the chip. And here you can see a network of resistors and capacitors to supply the voltage and stuff to the sensor. And Scott will talk about the
So
software.
to interface with the sensor itself, we used I2C. We haven't used that before, so it was quite a task learning about it. Pretty simple though. The sensor is a slave, and our Microblaze is acting as the master. So how it works is there's two lines, data and clock, and when data goes from high to low, that signals a start, which starts the clock, and you can send all of your data to the sensor. We're actually just reading to it, so we just tell it to read, and we pull our stuff back off of this. It gives us a 12-bit resolution, 8 bits, upper 8 bits being whole numbers, and the lower 4 bits being decimal values, so you get to 1/16th resolution of degrees Celsius. As a little extra thing, we also have conversions from Celsius to Kelvin and Fahrenheit, so we can accommodate many people's understanding of temperature. So, and we also have the LEDs here, which we use to test to make sure that we were getting the right values out. So before we go on, Rick's going to talk a little bit more about our hardware setup here.
Yeah, so we set up a high value, so when the temperature goes above a certain value, it would trigger an alert. And the alert is tied to this circuit here, where it would turn on this fan. Now, the fan itself runs on 12 volts, so we needed an external power supply to power up the fan. And so we had a transistor just act as a switch and turn it on. And so now we can demonstrate our sensor.
All right, so I don't know if you can see it right now, but it says the air temperature around the sensor is 25.8125 degrees Celsius. We have our fancy heating source here. Nice hair dryer. Okay, so we're just going to turn this on. And by the way, our limit is 30 degrees Celsius. We also have it set so it has to be above 30 degrees Celsius for 10 counts or 1 second, so we're not constantly going on, off, on, off, on, off. So we're going to heat this thing up. And the fan comes on. And why this might be useful is on a lot of computers nowadays is the fan won't turn on until you pass a certain temperature, because if it's already cool, there's no reason to cool it. So as you can see, it's going down faster with the fan blowing on it, and it turns off as soon as it passes 30 degrees. So
Cool.
that's our project.
Nice.